All right, on to the fourth and final page of the review, and we only have about 3 problems to go. So this one says, what is the length of the longest diagonal that can fit into the rectangle? Leave in exact terms. I'm going to tell you this is a terrible one to leave in exact terms because it actually can't be simplified when you get your answer. So if you were a little confused on how you could simplify the number you got, you can't. Okay, so what you can actually do on this one is notice that it's 3 dimensions. So normally Pythagorean theorem is just for 2 dimensions, but we're going to make it into 3 dimensions. So I'm going to do 12 squared plus 15 squared plus 10 squared equals the diagonal squared, which is what we want to find here. So I get 144 plus 225 plus 100 equals d squared. So I'm going to add them all up, 144 plus 225 plus 100, and I get d squared to equal 469. And some of you probably racked your brain on how to get that. It cannot be simplified, so we're just going to leave it as a square root of 469. Okay? All right, moving on to the second to last problem. And this one should be pretty straightforward. It's on your first quiz. So the first thing I'm going to do, it says find the perimeter, but first I'm just going to plot my points. So there's the point 2, 3. That's my point A. B is at 5, 7. And C is at 0, 5, which is right there. Okay, so if I make my triangle here, so I have my triangle. And now really, you can use Pythagorean theorem to find the length of, let's say, for example, CA. I've just formed a right triangle there. That's 2 up and 2 over. So to find the length of CA, I'm just going to do 2 squared plus 2 squared equals C squared, which is 4 plus 4, 8. So when I take the square root, I get C equals the square root of 8. And now if you wanted to, you could simplify that because it's the square root of 4 times square root of 2, which results in 2 square root of 2. So this distance right here is 2 square root of 2. Right, now I'm going to find the length of CB by drawing in a nice right triangle. So I go up 2 and over 5. So to find CB, I'm going to do 2 squared plus 5 squared equals C squared. So that's 4 plus 25 equals C squared. 29 equals C squared, square root. So C equals the square root of 29. So this distance right here is the square root of 29. And the last distance I'm going to find is from A to B, so drawing a nice right triangle. It's 3 over and 4 up. So to find the length of AB, you're going to do 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. So C equals 5. So this distance right here is 5. So then to find the perimeter, all I'm going to do is take square root of 29 plus 5 plus 2 square root of 2. And you can leave it like that, or you can type it in your calculator. Excuse me, give me a second to type this in. 29 square root plus 5 plus 2 square root of 2. Let me just calculate that 1 second. 2 times. And then plus 5 plus. I get 13.21. So my perimeter is 13.21 units. All right, so again, this one is just straight Pythagorean theorem from the graph. And then the last one we have is these circles, and these circles are really just specials. So always drawing your altitude straight to the x-axis. And this length, or this angle right here, is 300 degrees. The whole thing all the way around the circle is 360. So 360 minus 300 leaves me with that angle to be 60. So this angle right here is 60 degrees. The other thing I know is that this 1 right here tells me the length of my hypotenuse. So my hypotenuse is 1. So I basically have a 30, 60, 90 triangle with a hypotenuse of 1, which means to go backwards to the short leg, remember my shortcut is x 2x to get the hypotenuse, and times by the square root of 3 to get the long leg. So to go backwards to the short leg right here, I'm going to divide by 2. So 1 divided 2 is 0.5. Then I take my short leg and I times it by the square root of 3 to get my long leg. So I look back at my graph, and let me just do a little erasing here. This distance is 0.5. This distance is 0.5 square root of 3. Right is positive, but down would make that one negative. So the coordinates of that point are right 0.5 and down 0.5 square root of 3. Right, the next one, this angle is 210. This part is 180. So 210 minus 180 leaves me with an angle of 30 degrees. So this angle right here is 30 degrees. I'm going to drop my altitude in. And I'm just going to draw that triangle down here real quick. Again, this 1 tells me the hypotenuse is 1. To go backwards to the short leg, I divide by 2, so that's 0.5. And then to go to the long leg, it's 0.5 square root of 3. So I'm going to do a little bit of erasing over here. I know this distance is 0.5 square root of 3, and I went to the left, so it's negative. And I know this distance is 0.5, and I went down, so it's negative. So the coordinate of that point is I went to the left, 0.5 square root of 3, and I went down 0.5. So left and down make both of the coordinates negative. Right, and now we're on to the very last one. Notice now that we've changed our radius to 3, so this new hypotenuse is 3. 180 is this whole angle, so subtracted from 135 leaves me with a 45 degree angle. So remember, 45, 45, 90 is x square root of 2. So I know the hypotenuse here. Normally I multiply by the square root of 2. This time I'm going to divide. So to find this side right here, I'm going to take 3 divided by the square root of 2. Can't leave my answer like that, so I'm going to multiply by the square root of 2 on top and bottom. So I get 3 square root of 2 over 2. And what's nice about a 45, 45, 90 is once I know one side, I also know the other side. Again, I went to the left, so it's negative, but I went up, so it's positive. So the coordinates of that point are negative 3 square root of 2 over 2, comma, 3 square root of 2 over 2. Because I went to the left, which makes the x coordinate negative, and I went up to make it positive. Alright, hopefully this answers some of your questions. Please come with additional questions tomorrow, and have a nice night.